So hello everyone, in this lecture we are going to see one more performance matrix, which is speed up. We had already seen, right, efficiency in a previous lecture, right? This is also one of the performance metrics of pipelining. Now in this lecture we will see about speed up. So what is speed up? Speed up is a measure of how much faster the system performs, right, when an improvement is pipelining is applied compared to the original system. See, here what we are doing is we are taking we are applying a pipelining on a system, okay, on some original system, and then we are seeing how faster that particular system became after applying in a pipelining. Okay, that is what this speed up is all about. So we can see how many faster the new system is. See, why I have taken this is, see, new system, right? You might be thinking, see, I am not talking about that the original system, whatever is there, I am not trying to improvise it. Okay, that is not the meaning of this. Okay, the thing is, okay, I will explain. I don't know whether you understood. Okay, we will come to this part. What we are doing is we are taking one original system, okay, and we are trying to try to execute that original system using without pipelining, okay, without pipelining, and we will see how much time it is taking to execute that system, okay, or what would be the clock cycle required to execute that original system without pipelining. Then we will note down that measurement, okay. Then what we will take the copy of this original system again, and we will try to execute with pipelining technique. We will try to execute with pipelining technique, and then we will call that original system 2 as a new system. Then we will see how much time it is taking, okay, or how much clock cycle is required, and that is what the measure, and whatever the difference we will see, or whatever that is what we are talking about speed up, right? There would be some improvement without and with pipelining, right? That is what the speed up is all about. So we will clearly, we can see clearly how much faster the pipelining would be, okay, pipelining technique would be compared to the non-pipelining technique, right? That is what speed up is all about. Okay, fine, this much you understood, right? And speed up is a measure, and one more thing you have to understand, speed up is a measure according to load of instruction. So we measure speed up according to load of instruction. That means, what I mean is, what would be the speed up whenever we try to execute a 9 instruction. So whenever we want to calculate a speed up, we try to say that for 9 instruction what would be the speed up, for 10 instruction what would be the speed up, for 20 instruction what would be the speed up, or for 100 instruction what would be the speed up. In this way we try to measure the speed up, okay. So some fixed number of instruction is already there, and then we try to calculate the speed up, right? So that's why it is written, it depends upon the load of instructions, how many number of instruction we are taking. Now we will see about the formula also, okay. So this is the generic formula for speed up, right? So it is a time taken or a clock cycle required to execute without pipelining, or clock cycle required or time taken to execute with pipelining. If you divide them, okay, see, this is denoted by TWP and this is denoted by TP, okay. So when you divide it, then we will get a speed up automatically, okay. So this is the generic formula to calculate speed up, right? Now let's see one example so that you can understand this formula better, okay. So we have already seen that phase time diagram, right, for 9 instruction, right? This phase time diagram is created for 9 instruction. So with this only we will try to explain this formula. I will try to explain this formula, and we will calculate the speed up also for 9 instruction. I told you na, here we are trying to measure the speed up according to 9 instruction, okay, because we have already seen this particular example. So we will try to calculate the speed up for 9 instructions, okay. Let's see. Okay, now let's try to calculate speed up for 9 instructions. Suppose number of instruction n is 9, which is already, we know that we are going to calculate speed up for 9 instruction, that's why n is 9, and number of stages or phases m is 4, okay. How you got 4? Because of this, right? We already knew that there are 4 stages, right? Now see, if it is 4, then it is, we already know that it is equivalent to number of clock cycles, right? So 4 stages means it is equivalent to number of clock cycles, which is also 4 clock cycles. See, what does it mean? That means that first instruction has to go through all these 4 stages at the beginning, okay, when you are using a pipelining. That's why we are talking about 4 here, right? I explained all these things previously. Now you have to calculate speed up, okay, using this. So what would be the speed up? Speed up is S, right, denoted by S. Then time taken without pipelining and time taken with pipelining. What is the time taken without pipelining? We already knew the formula. There are n instructions, right? If there are n instructions, that means if there are 9 instructions, then each instruction will take 4 cycles, that means 4 phases, right? That is without pipelining. And with pipelining, what would be the formula? First instruction will take 4 clock cycle. After that, remaining means 9 minus 1 instruction, that is remaining will take only 1 clock cycle. That's it. Now you try to solve it. 9 4s are how much? 36. Then this is 4 plus 8, right? 36 divided by 12, that is 3, right? The speed up is 3. So what does it mean by 3? You got the value is 3, right? What does it mean? This means, see, I had written here, whenever we are trying to execute 9 instruction, we are able to execute 3 times faster using pipelining. That is the meaning of this 3. Speed up equal to 3. Are you getting it? Fine. Now, understanding this, we can further generalize the speed up formula also, right? After understanding this part, we can again generalize those speed up formula. What we can do is, see, speed up is equivalent to time taken without pipelining, right, and time taken with pipelining. What we understood is, suppose the number of instruction is n, then each instruction is taking m clock cycle, that is m phases, without pipelining, right? And with pipelining, what happens? First instruction will take m phases, that means m clock cycle, and after that remaining n minus 1 instruction will take only 1 clock cycle. So we can see this is also one formula, right? So how can I write it? N m, right? N into m divided by m plus n minus 1. Can I write like this? So we can see we got one more formula here, right? So whenever I talking about speed up, you can directly write this. Speed up equal to n into m divided by m plus n minus 1. This is also one kind of formula. This is also one formula which we derive now. Okay, fine. So I hope you understood all these numericals and everything. Okay, now we will further analyze the speed up in our next lecture also.